Hello, my name is Wilberto Montoya. I'm going to do this presentation as a final project for the Machine Learning for Product Managers course from Duke University. For that, I'm going to use two different models, linear regression without regularization. Also, I'm going to use lasso regularization and ridge regularization. The second model I'm going to use is a decision tree. For that, I'm going to tweak a little bit the MaxDeep hyperparameter to check the best performance. The performance actually is going to use the score provided by sklearn. I use in Python, and sklearn is the library that I choose to do these models. So let's go in. So first, I'm going to load the data. And to analyze which feature I'm going to use, I'm going to use this graph that is heat map. As you can see, we are trying to estimate this power output. That has a very strong relationship, inverse relationship with temperature and vacuum. Not that much with the other two features, but actually because are over 5.2, well, this one is kind of a little bit less. I'm going to keep all these features. I don't have any 0, like that. So I'm going to keep it for now. So let's run the linear regression. For that, I'm going to split the data. I'm going to use a training test split from sklearn to split the data into different segments, the test and the training. I'm going to use the first model, that is linear regression. I'm getting a score that is 9 to 9. That is pretty good for training, and for testing a little bit less, but it's still pretty good for linear regression, I think. So linear regression is a good initial model as a reference. So with lasso, I can see that I'm getting a better performance. So that may mean that I can remove a feature, because remember, lasso can remove features from the model. But once I run ridge, I can see the ridge gets even better performance than lasso. So ridge doesn't remove anything. So I guess that it has some advantage to keep all the features in the model. So I'm going to keep it. Let's plot the results for testing. As you can see, with lasso, it meets 2 points here, and the rest is pretty much the same. Ridge and regular regularization, you can find linear regression, can find these ones, but not the other. So let's see what the regression tree can do, decision trees. So I'm going to use 4 different hyperparameters. I'm going to train and predict the models, and see here we have 3 and 4 kind of miss this point here, but deep 5 and 6 actually hit this one that was missed by linear regression. So pretty good performance with decision tree. So let's see the scores. And yeah, you can see that we plot the scores. We are getting some overfitting here. It starts getting overfit. Yeah, the gap is getting wider and wider. So that's the reason I will recommend use 4 or maybe 5. You want a better performance, but over 5, if the overfit is, the gap gets too wide. So the model is too complex for these situations. So finally, I'm going to plot everything to compare everything together. But in this case, I'm going to use another trained data that is with shuffle through. And I mentioned that this is a time series data, so time series shouldn't be shuffled because it has some seasonality or some tendency that it needs to be kept in your training. But because we are using line regression and decision tree, really shuffle doesn't have any meaning. This kind of model doesn't consider that kind of seasonality or tendency. Something weird that I found here is you can see the test data for shuffle. It has better performance than trained data. That's supposed to be because there are some outliers in the last part of the data that it may be some wrong data, but I don't think so. I think it's some seasonality. Maybe we have temperature here. Maybe it's a hot weather or cold weather that this has some influence in the model. So let's see if we can see here, if we keep testing, we reach a point that actually these outliers are in the test data, and then it has less score. For now, I will say that I recommend linear regression with ridge that gets better, similar performance that decision tree with 6 dips, but it's a more simple model, so I will recommend to use that. Well, that's everything. Thank you for your time.